Hey guys, Victor here. We're going to take a look at doing a crash course in Java programming, and more specifically, these are the topics that we'll cover. So first thing, let's take a look at a full program and we'll show how exactly it works. So we have our JetBrains and IntelliJ IDE, and I've loaded in I've created a program here that will read an input from the console and then output something. So let's just take a look at how it works. So I'll click run. I have a shortcut on my keyboard for run. And now it's waiting for an input, so we'll put in any word here. So we'll say Victor, and then the program outputs Victor back. And how exactly does this work, you might ask? So you first import some necessary packages, then you declare your our class, so we can eventually we'll be able to add other objects in here so we can reference this input class if we'd like. And now this main function will take in an argument. But we haven't specified one. We can cover how exactly that works later. But basically what it does is it creates a reader object, and this is the syntax for creating the input for this for the console reader. And then you set you create a string variable called name, and it'll get set to be equal to the line that you've just typed into the console. And finally, once you've inputted that line, we will just spit back out to the console that same string that we've inputted into the console. So then it'll do, so this is the syntax to print back out, system out println. Now, what is Java used for, you may ask? So this article goes over it pretty well. The most unique thing is probably the Android apps. I guess something that most people are familiar with is Java runs on Android. I mean, sorry, Android runs on Java. Then you have server apps in financial services that are common, as well as Java web applications, software tools, trading applications, and as you can see, the list goes on. It's a very flexible language that has stuck with a lot of different applications. Okay, now we'll look at what that public static void main string args exactly means that we glossed over before. So this article has a pretty good explanation of it. We'll walk through this. The public stands for basically that the program can't see the method, this method. If it was private, you'd have to actually call the class somehow, and then in order to access a private function. But since it's public, you can access this outside of the class. So that's why we'll have to have it be public in order to make it run. And you can see here what the error would be if we don't include that. Static is there because Java expects it to be there for so that it knows things are not changing in this function. The void is there as the return type. So what does the main function return? It won't be it wouldn't be returning any integer or anything or string. It would just we would have to return void. Then the main is we have to have main there because when you run the Java program, it'll look for the main function, and if you don't have a main function in there, it'll also break down. And the string args is there in case you want to use some extra command line arguments. Let's say you were running your program in the command line as shown below. You'll be inputting this 1 space 2 space 3 string into your program. So as you can see by the example they've run, they're basically spitting back out on a new line each character of this string. That just about does it for that. Okay, now let's take a look at the difference between a method, function, and a class with some examples. So first of all, the class is what you see here. It contains functions and methods that support editing and creation and display of objects. So, for example, I've created the object person, and I'd like to be able to use some functionality related to a person in my class. So, as an example, we can start simple. Let's say here's an example of a function as opposed to the method, and this function will just add two numbers together and return that sum. And we can see that how it's run within this public static main string args statement. So when the program runs, it'll assign num1 to 1, num2 to 2, and then it'll assign a new x variable to the result of the add function. And it'll just add these two numbers together and print it out. So we'll go ahead and run that. And what happens is our function output is 3. And now methods are different. What makes methods unique is that they'll actually interface with a private aspect of the class. So, for example, a method will have, in this case, we can set a name for a person. So this will interface with this class. So our name that we input into this method will be set to that particular person's name. So how you implement that is you create a new person. Let's call him. Let's call the variable s, and we can set s to be a new instance of this class person. Now with this new s object, we can invoke this method that corresponds to this function up here, and that will set this object's name property to what we have here, Victor. And now we can create another variable name, and we can invoke this other method that uses this private variable that will return this name. And note that we did have to declare this name to be part in order to be able to use these functionalities. So then once we get the name using this function, we can return the name with the system.out.println function here. So let's see what that looks like. We just run it, and we can see our methods output, and it looks like it was successful. Okay, now what is an import, and how can it be used? So here's an example that has 3 imports. It's what we showed before, and the imports are IOException, which has additional functionality for error handling. There is the import input stream reader, and this allows to get our input text from the console. And then we have our buffered reader import that will take this input stream reader object, and those provide functionality that so that you don't have to write the complete code for these individual packages each time you want to use them. It makes it for a nice clean code setup. So now let's give this a run and see how it works again. We'll type in something, and we get something back from the program. So it's a successful program there. Okay, now let's take a look at some healthy syntax practices for Java. So one thing we want to make sure of is that we comment where things aren't obvious. So maybe we think that the set name isn't too obvious, so we can give a comment here. So ideally you'd be commenting anything that's unclear. Another good practice is to make sure we only make things public if they really need to be public. This will it could cause problems if functions are public when you don't expect them to be. And if it's not necessary, it's good to keep it private. So we'll go ahead and change all these to private. And we'll keep this as public because we might want to reference this from other files. And this has to be public for the reasons we discussed before. And okay, next we're going to take a look at Java tests and how we can create one with some examples. So we'll go back to our person class. This looks the same as before. Now we've created a test class where we've imported the person class along with some test functionalities. So we'll go into our tests class and it'll go straight to the main function. And first we create a new person like we did before. We set the name to what we want to, and then we get our name and then store it in the name variable. And then we'll print out what that name was. And now here's where the test comes in. We have an assert equals function where we can say, hey, I expect there to be this text in this variable, and if that isn't true, give an error and stop the program. Otherwise, it'll continue and it'll print out no error. So let's give this a run. And as you can see, since we set the name to Victor, but you expected Victor 2, there was an error. And it tells you exactly what happened. It expected Victor 2, but it was actually Victor. Similarly, we can do this with another example. So we could get rid of the 2 there, and we can see if it runs. Okay, so it continued running, and you can see here that there was no error because the expected output and the actual output were the same. Now let's try another name. Let's say Julia. And let's change this a little bit to test it out. Julia ASD. Let's see how that runs. And again, there was an issue. And now we can get rid of the extra characters and run it again, and we get no error. We can try again with something else. Say Tony. Now we'll check against Tony Q. And out comes an error. Out comes a nice descriptive error there. And we'll go ahead and change it back to what it should be. And give it a run. And no error. That's how tests work. Next, we're going to take a look at exceptions in Java and how they can be understood, used, and evaluated. So here's an example. Here's our test person class again, but I've edited out the person class material, and we're just actually only going to be throwing an error, then catching that error, and then doing something else after the error is caught. So we'll go ahead and run it. Okay. So starting off, it tries the following. It prints out the error. It prints out this text. Then it gives an error as a result of 1 not equaling 0. So in that case, it invokes this catch functionality, and this line allows this text in red to be printed out. And after that's printed out, it goes on to the finally functionality, which prints out another line showing that you can do something after the error is caught. And what's also interesting is Java has some pretty sophisticated functionality with error catching, and you could potentially have a specific method in your class or function in your class that throws a specific exception. And how this is useful is that once this is thrown, if it needs to be thrown, maybe because one data set doesn't fit another one in a certain way, whatever your reason may be, you can actually catch that particular exception when you run that particular method. So it can be a very precise way to identify and handle the errors, which could allow for more sophisticated functionality around error handling. Next, we're going to be looking at these questions. What are IDEs, and which ones are Java friendly, and how are they to be used? So IDEs are actually integrated development environments, is what it stands for. And the following are the two most popular Java IDEs. One is Eclipse IDE for Java, and the other is IntelliJ IDEA, made by JetBrains. And IntelliJ happens to be the one that we've been using this whole time. And they're to be used by you can basically organize all of your files and dependencies and imports all within this environment, as well as running your program all in the same program, which makes it easy for development. Otherwise, another way to do it, which is less simple, is to use a text editor for all of your code and run your Java program from the command line, which I guess would require switching between two windows, which is not as efficient. And an added bonus of IDEs is you can generally have autocomplete functionality of variable names, as well as class method lookups, and a whole host of various extra features that people find very convenient. Next, we're going to take a look at how to debug a Java program. And this is actually yet another feature of IntelliJ IDEA that is nice. That's that there's a debugger built in. So all we have to do is set a breakpoint around where we think there might be an issue in our code. So let's say we thought that this line might be giving us problems. So we'll go ahead and set a breakpoint right before it. So it'll actually stop right before running this line. Then we can step to the next line and so on to debug. So let's give this a whirl. Okay, just click the debug button there. And now the program is now stopped right before executing this line. And we can also see that this IDE also provides some nice extra information to the side of these lines, showing you what the variable consists of. But now let's go ahead and step over this current line and look at the next one. Okay, now maybe we want to go dig into this certain method so we can step into the program. And it brings us to what the meat of that function is. And now we see that the name is ASD, and that's which was already assigned in the previous step. So that's what it's going to be returning, hopefully. So we'll see if that happens. So we'll step over and continue the program. And we'll step over again, and it looks like name was in fact assigned the correct thing. You can also explore the variable names here, add watches. Maybe the name wasn't there already. You could have just added it here as well. Or you can also add any complex calculations, like let's say this could be something we're interested in. We can add that as a watch as well. And that shows you the output of this phrase of code. So then we can continue the program. Maybe we figured out our issue and we can just run the rest of the program to the next breakpoint, but since there are no breakpoints left, it'll go to the end. Thanks for joining us on Exploring Java, and we'll see you next time. And here is the work cited if you're interested. Thanks for joining us on Exploring Java, and we'll see you next time. And here is the work cited if you're interested.